So this is just a quick overview video of the work we've been doing related to decimals, their connection to fractions, and the visualization that I'm hoping that you walk away with. So take a look up here. In my best drawing I could possibly do, I've got a whole, let's call this a rectangle. I've got a whole rectangle that I cut up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. So each one of these individual pieces, like say this strip right here, that is called a 1/10 because that's what a 1/10 is. A 1/10 is what you get when you take a whole something and cut it up into 10 equal parts, which is what I've done. So there's a 10th, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10 makes a whole. So suppose we wanted to represent the idea of 0.4. Now on this side of the decimal is our whole place values, like the ones place, 10 ones, we move over to the tens place, 10 tens, we move over to the hundreds place, etc. But now on this side of the decimal place, we're going to start keeping track of these fractional amounts. So when we took that whole and cut it up into 10 equal pieces, we're saying how many 1/10ths do we now have? So if there's a 4 in that spot, your thinking is, oh, you've got 4 1/10ths. There's 1 1/10, there's 2 1/10ths, there's 3, and there's 4. So 4 1/10ths, 0.4, 4/10ths is 4 of those, in my case, green strips. Now we can think of that in multiple ways. So suppose instead of, let me use red for this, suppose instead of cutting up into 10 equal parts, suppose we cut up into 5 equal parts. So there's 1, there's 2, 3, 4, and 5. So kind of imagine that instead of cutting up into those 10 strips, that I cut up into those 5 strips that I've highlighted in red. So can you see that 1/2 of the 5, 2/5, 2/5 as a fraction is the same as 4/10ths. So we could accurately say this, 0.4 or 4 1/10ths or 2 1/5ths all represent the same quantity. Now, the idea here is we want you to be flexible. It's not that you should do this or you should do that or which way do you want me to do it. Don't think like that. Just think flexible. You should be able to move in between. If somebody's talking about a 0.4, a 2/5, a 4/10, all of those should make sense to you in terms of your visualization. Now what if you took that same rectangle that we had cut up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 strips like up here? What if we took each one of those strips and cut it up into 10 equal pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 1/10 up here was now cut up into 10 parts. And each of them was cut up into 10 parts. So in terms of these little pieces here, there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So each one of, each one of these is a 1/100th, because that's what a 1/100th is. You take a whole, cut it up into 100 equal pieces, use your imagination that those are indeed equal. You cut it up into 100 equal pieces, each piece is called a 1/100th. So imagine that you had, like up here, we had so we called that 4/10ths up above, but now look what we could call it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 100ths, 20 100ths, 30, 40. We could call this 40 100ths. That's another way you could say it. 4/10ths, 40 100ths, 2/10ths, 0.4. They all represent the same quantity. Now what if I wanted to think about this? Those 40 plus 1, 2, 3, 4, 5, 6 more. What we have now in terms of a decimal representation, 0 point. So in this place we're keeping track of tenths. Now take each of those 1/10th strips, cut them up into 10 equal pieces, well, there would be 100 of those. So now we're keeping track of how many 100s we have. So in this case I have 10, 20, 30, 40, 1, 2, 3, 4, 5, I have 46 of those 100ths. Now that 46 100ths is the same as 4 tenths and 6 hundredths. That's why we put 4 tenths and 6 hundredths. But it is also 10, 20, 30, 46 of these individual pieces. It's also 46 100ths. So here we can say 0.46, 4 1/10ths and 6 1/100ths. I hope you can see that that's what we're showing here. But we can also say 46 1/100ths. Now are you ready for some serious flexibility here? Check this one out. What if instead of cutting up into individual pieces like this, what if I counted by twos? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what I would have counted as 20 individual little pieces, what if I now counted them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I keep going. And I keep counting individual pieces. If I'd have 10, I'd have 20, I'd have 30, I'd have 40, I'd have 50. In terms of little red pairs of those little pieces, I'd have 50 of them. So now, let's count how many of these red pairs I have. Red pairs. Red pairs. So there's 1, 2, 3, 4, 5, 6, 10, 20, 21, 22, 23. So instead of cutting up into individuals, if I cut them up into pairs, there would be 50 of those pairs. I have shaded in 23 of them. So another way to see this, same amount of shaded space, there's 23 of those 1 1/50ths. So you can think of this as take the whole, cut it up into 50 of these. So 1 1/50th. I have 23 copies of those 1 1/50th, same amount of space. So 0.46, 46 hundredths, 23 50ths, all are representing the same thing. Now watch this. Take one of those 1 100ths. I'm going to blow it up. This is a magnification of what I've done here. Take that and cut it up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Imagine doing that with every one of them. Cut this up into 10, this up into 10, 10, 10, 10, 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 200, 300, 400, 500, 600, 700, 800, 900, 1,000. There's 1,000 of these inside of this square. So we went from one whole rectangular piece, cut it up into 10 equal pieces, 1/10. Cut it up into 100 equal pieces, 1 100ths. Cut each of those up into 10, 1 1,000ths. So suppose I had what I had before. I had the 4 tenths, 6 additional hundredths, but then I took one of those 1 100ths and I shaded in, let's just say 3. That's 1, 2, 3 1,000ths. So as a decimal, what we're saying here is you have 1, 2, 3, 4 1/10 strips. You have 1, 2, 3, 4, 5, 6 additional 1 100ths, and then you have 1, 2, 3 additional 1 1,000ths. So 0.463. There's no, I didn't shade in a whole piece here, none of those. But I got 4 1/10ths, I have 6 1 100ths, I have 3 1 1,000ths. So we can write that as a decimal, 0.463. But we know that that's really 463 1,000ths. But when you see that 463 1,000ths, what you should see is all the pieces. Not again, well, do you want me to do it this way or this way? I don't want you to do it anyway. I just want you to understand all of it. You should be able to see this as 1, 2, 3, 4 1/10ths. And there's 1, 2, 3, 4, 5, 6 1 100ths. And there's 1, 2, 3 1 1,000ths. Or I could just say 4 tenths. You have 4 tenths, 6 hundredths, 3 thousandths. This is just breaking it apart. You could also see that there's 10, 20, 30, 46 100ths. There's 46 100ths. There's 463 1,000ths. If you counted each one of these, there's 10 there, 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 10 there. There's 463 of these. You should see it all the ways that you can see it. Now, why is this going to be useful? The reason this is going to be useful is because when we start adding these things, your thinking is going to lead the way. So imagine, let's go to this 0.463 that I've represented here, and suppose you want to add on an additional, what did I do? Oh, let's do this, 1, 2, 0. Now if you see it the way we're asking you to see it, the addition of this thing should go pretty smoothly. So look, do you have any whole rectangular pieces? Nope. But now, in terms of tenths, in terms of these strips, how many do you have? You have 1, 2, 3, 4, and we're going to add another one. How many individual little squares? 1, 2, 3, 4, 5, 6, and then we're going to add 2 more. And then how many of these little tiny 1/1000th pieces do we have? We have 3, and then we're going to add no more. So when we add this together, this all adds up as shown. My computer stopped. Now notice what I did here. I started with the strips, and well, I really started with the whole pieces and said, I still don't have a whole piece. But I have now 4 plus 1. I have 5 of these green strips. 6 plus 2, I have 6, 7, 8 of those little squares. And I have 3 of those little tiny pieces, 1/1000ths. Now I know what you're thinking. Well, what if you had 0.463 and you wanted to add 0.258? It's not a problem. Just do it exactly the same way. Watch. So I don't have any whole pieces, but I've got 4 strips. 1, 2, 3, 4. I'm going to add an additional 2 strips. 1, 2. That'll give me a total of 6 of those strips. Then I've got 6 of these little squares. 1, 2, 3, 4, 5, 6. I'm going to add on 5 more. That would give me 11 of those. And then I have 3 of these little guys. I'm going to add on 8 more. 1, 2, 3. I'm going to add 8 more. 5, 6, 7, 8, 9, 10, 11. I'm going to have 11 of those. So my answer is I have 6 tenths, I have 11 100ths, and I have 11 1,000ths. Now this is absolutely right. It's correct. It communicates. You're hearing my voice. I'm telling you what that means. But our society does not view that as useful. We usually do something like this. Now if you have 11 of these little guys, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, what we really have is another 1/10th strip. So we're going to take that 11 of those and say, well, that's really another 1/10, and then an individual square. So those 11 that we ended up with, imagine 10 of them is a strip plus 1 more. 10 of them is a strip, so I now have 7 plus 1 more. Likewise here, 11 of these guys, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of those guys makes a full 1/100th. So 10 of those is going to make a full 1/100th. The 11th one is just the 11th one. So when you add these, you can totally think your way through it. You have 6 strips, you have 11. That means I'm going to have another one of those, up to 7. And then I have 11 of those, which means I'm going to have another one of those, which brings it to 2 and 1. So 0.463 plus 0.258 is going to give me 0.61111, otherwise known as 0.721, which is probably the way we would prefer to report that answer. So slow me down, pause this, rewind it, listen to it again, try it on your own paper, write it out. Get a piece of paper out and do this for yourself and see if you can make sense of how decimals, fractions, pieces, visualization, put it all together. Have fun.